Take a look here, folks. Find the derivative. I divided everything by 2. Then it does factor pretty nicely by grouping there, or just regular factoring, sorry. 2/3 and -2 are your 2 critical values. So I have 3 intervals, -8 to -2, -2 to 2/3, 2/3 to infinity. All right. So -infinity to -2, plug in at -3 right there. You would have a negative times a negative, which is a positive. F of x is increasing. -2 to 2/3, plug in 0 for sure. Well, if you plug in 0, you're just going to get -8 or -4 there, or a negative times a positive, which is a negative. So it's decreasing on the interval. And 2/3 to infinity, let's plug in 1. You get a positive, a positive. A positive times a positive is a positive. So it's increasing. F of x is increasing on 2 intervals and decreasing on 1 of them. All right, on 11 here, folks, you have a rational function. So you're going to have, when I take the derivative, again, low d high minus high d low, cleans up relatively right there. Okay, so this one's not fantastic, and I'm not going to finish all of these because you get a terrible answer. So just know how to do this. Now, -4 would count as a critical value. That's why it says that. You would have to count -4 as a critical value because it makes your derivative undefined at that point. And then those other 2 are bad, so we're just going to stop there on Tuesday. All right, the ones you get on your quiz, come out nicely, like a 9 and 10. So that is my fault. All right, again, we're going to do the same kind of thing here. This is the Big Daddy problem here. Everything involves. We're going to go through most of these. Again, some of these are not swell to look at, but you'll get the point. Find the intervals of increase, decrease. Find the min and max values. Find the intervals of concavity and any inflection points. Okay, this is worth like 6.5 or 7 points. You're going to have 2 of these on your quiz. First off, find the first derivative. Okay, set it equal to 0. You have 2 critical values of 0 and 2. So right up here, 2 critical values of 0 and 2. So you got your 3 different intervals then, -infinity to 0, 0 to 2, 2 to infinity. And then plug in some points. You can't use 0 as a test point, bummer. I'm going to plug in -1 for the first interval. I would have a negative times a negative, which is a positive. I'm going to plug in 1 in my second interval. I would have a positive times a negative, which gives you a negative. And finally, like plug in 3, positive times positive gives you a positive. So f of x is increasing on 2 intervals, and just decreasing on 1. So then, in order to figure out a min or max point, guys, if it goes from increasing to decreasing, that's a maximum. If it goes from decreasing to increasing, that's a minimum. So that transition point of 0, I plug 0 into f of x, I get 0. That means I have a local max at 0, 0. I take that 2 and I plug it into the original function, and I believe, again, check this, I believe I get -8. That means I have a local min at 2, -8. All right, next part is the second derivative test. So I take that derivative right there, that first derivative, and I take the derivative of that. I get 12x minus 12. Set it equal to 0. I get x is 1. So -infinity to 1, 1 to infinity are my intervals. I test for concavity. That's all about the tangent line. If the graph is above the tangent line, it is concave up. If the graph is below the tangent line, then it is concave down. An inflection point is when it changes from concave down to concave up, or vice versa. All right, so -infinity to 1, I'm going to plug in 0 right here, and I get a negative. So 1 to infinity, I'm plugging like 2, and I would get a positive. That's how I figure out concavity. Again, I do have an inflection point because it changes from concave down to concave up. My inflection point is at 1, that transition point, 1, 1. I plug 1 into the original. I always plug it into the original. I get 2 minus 6, which is -4. All right, so definitely want to know how to do that type of question in its entirety. So honestly, after that, I'm just going to kind of go through how you do the rest. Okay, take the first derivative. Set it equal to 0. Those are your 2 critical values. Those are your 3 intervals, -infinity to 0, 0 to 1, 1 to infinity. Find some points that work. Really, for 0 to 1, you're going to use 1/2. Okay, -infinity to 0, maybe -1. 1 to infinity, use 2. Anyway, it's increasing on just that interval 0 to 1. It's decreasing from -infinity to 0, 1 to infinity. Again, when it goes from decreasing to increasing, that tells me that 0 is going to be a local min. When it tells me it's going from increasing to decreasing, 1 is going to be the point for my x-coordinate for my local max. Plug those into the original value, and there's your local min and max. Take the second derivative, so work with this here. Take the derivative of that. X is 1/2. All right, this is not organized fantastically. Not a lot of room here. You have a lot more room on your quiz. -infinity to 1/2, 1/2 to infinities are your intervals for concavity. I don't know, plug in 0 there, and you'll get f prime of x is positive. Plug in 1, you get f prime of x is negative. So you have concave up, concave down. That means 1/2 is an inflection point. Plug 1/2 into your original f of x to find your inflection point. Okay, that one's not too bad. And here's 14. Take the derivative, factor 3 out. If you were to factor a negative, you'd have to keep that in mind. You have to keep that in mind for your when you plug it in to figure out if it's really increasing or decreasing. Two critical values of -1 and 5. That means you have 3 intervals. All right, fine, nice test values. Plug in 0 to your middle one. Plug in -2, 6, whatever you want. 2 intervals of increasing, 1 interval of decreasing. When it goes from increasing to decreasing, that is a maximum point. So plug -1 in to your original function, f of x. You get -112. That's your maximum point. Increasing or decreasing to increasing means you're at your bottom. That's a local min. Plug 5 into the original. You get -96, I believe. That's definitely a minimum point. Second derivative test. Okay, take that first. So take this one right here. Take this one right here. Again, it doesn't matter. If you took that one right there, you'd also, when you set it equal to 0, it would also get 2. All right, -infinity to 2, 2 to infinity. Concave down, concave up. You have an inflection point at 2. Plug 2 into your original. And lastly, folks, this one's not fantastic. Okay, low D high minus high D low. It's factors out nicely. Again, you have to set the bottom equal to 0 because -8 is a critical value because it makes your derivative undefined. If you set the numerator x times x plus 16 equal to 0, you get 0 and -16. So your intervals that you would test are -infinity to -16, -16 to -8, -8 to 0, 0 to 16. We see this sometimes, folks. A lot of times it alternates. When it doesn't alternate, that probably tells you that, you know, when you have 2 straight intervals of decreasing, that -8's got to be something special, and it is a vertical asymptote. So when I write it, I can't simply say it's decreasing from -16 to 0, because at -8 you have a vertical asymptote. You have a vertical asymptote there. So we're going to write it like that. And folks, just plug in. So you have a trend when it goes from increasing to decreasing. -16 is going to be local max. Goes from decreasing to increasing, then 0 is going to be a local min. Plug those in. Second derivative test is going to be little challenging there. We'll talk more about that one on Tuesday. I'll finish that one on Tuesday. Folks, there was nothing on that last page there anyway. Quiz is easier than this quiz review, I will say that. You do need to know your trig a little bit.